Hello guys, today we will see into what is instantiation and how to do and write a code in using an instantiation method in Verilog. So so far you have already learned how to create a module in Verilog. So good amount of tutorial and exercises are covered in the previous tutorial, so you can please prefer through the previous tutorials. So first of all, what is module? So a module provides a template from which you can create a actual objects. So when this module is invoked, it creates a unit object from the template, and each object has its own name, variables, and its own parameters and input output interface. So the process of creating objects from a module template is called instantiation, and the objects are called instances. So for example, I will be taking a very simple example for you to understand how to do instantiation. So example I am taking is using building a full adder using half adder. So I request you to focus and stay connected as we're gonna build the final code of full adder using half adder from step by step from the beginning. So let's switch to the coding part and create this file. So first we're gonna create a half adder. So let's switch to the xilinx platform. I'm taking a new source. We are creating a verilog module, and I am creating a half adder. So this is the instance. Next and finish. So let me first show you the half adder. So there we will require A and B, two inputs, two output, carry and sum. So the logic for carry is A dot B, A and B, and for sum is A XOR B. And the same thing we will implement it in the code. So let's take A, B and carry and sum. So far now you are very well aware that how to define a variable with what is the input and what is the output, and output is carry and sum. So now we are done with synthesis part, and this is the half adder, and there is no error. We have successfully completed the synthesis part, and now let's switch to the full adder part, and this half adder will be working as an instance for the main module. So let's see how to build and implement the full adder using half adder. So first of all, looking at the circuit diagram of the full adder, so you can see that this is the half adder using and XOR gate. So this is the XOR gate and one more XOR gate and AND. So this first creates an half adder 1, and this second two gates combination creates a half adder 2. So both are combined and their outputs are ending outputs are taken into the OR gate, and that gives the final carry out of the full adder, and the sum is given through the second XOR gate. So this is how the full adder is created using a half adder. So that also teaches us that half adder can be used as a instance in the full adder, because see guys, we are having a same logic over here and over here. So let's see, switching to the coding part, and let's see how we can build it. So I'm taking a new file, a verilog module, and the file name is full adder. I'm taking and then next and finish. So here we will have three inputs: A, B, C in, and C I am taking as carry, C out I am taking as carry out, and sum as the final sum of full adder, and defining inputs A, B, and C in are the inputs. Output C out and sum are the outputs for the full adder. And now it's a time to define uh, half adder as an instance module, so that will be used as a full adder in a full adder module. So here, so far we have defined the total number of inputs and outputs that are gonna used in creating a full adder. Now we will give the logic of using a half adder as an instance module in a main logic of full adder. So half adder. So the inputs will be A, B, A, B. So here comes a catch. Go to the half adder code. Here you have to define the instance exactly same as you are defining in the your instance module. So first we gave inputs and then we gave outputs. So similar way here we will give inputs of this module, and then the output will be. So for having outputs, we need to define some wires. I'll taking W1, W2. So let's say our carry is our sum is W1 and our carry is W2. Can we go back to the half adder and see? So first carry is defined and then sum is defined. So it will be opposite of that. So first carry is defined and then sum is defined. So here W2 will come and here W1 is come. So I am creating it from the very basic so that you don't get confused over here. Then second half adder. Second half adder inputs are output of XOR 1, output of XOR 1, that is the sum output of XOR 1. So W1 will be the first input of half adder 2, and the second will be C in. Then we are supposed to define carry as per the defined instance in a half adder module. So C in, so the carry for the second half adder is, I am taking the wires as W3. So here I will get a carry and the sum is my final sum. You got this? My sum is my final sum. So that will be this sum. Sum will be my final sum. And finally one logic will come to get the final C out. So we will assign C out is equal to ORing operation will come. So ORing of what? So ORing of first carry. So first carry was W2. So ORing of first carry or and second carry. So second carry is W3. And now we will define the gate variable into which we are taking this instant module. So for this we will give G1, and for the second instance module we will give G2. And let's save it and synthesize it. So synthesis is done successfully. We will see RTL schematic. Step on the middle, zoom to fill view. So these are your instance module of halfadder. Let's step in the middle, zoom to fill view, second module. So this is XOR, this is ending, and this is ORing operation. So it is similar to the implement in design. So hence we have successfully built a full header using an instance module of half header on the xilinx platform. Let's see some simulation behavior module also, and then we will create a test bench. But first we will see it by using a force constant values. So we were on full header. Okay. Simulate the behavioral model. So these are your inputs A, B, and C in. Let's give some constant values. I'm giving it as 1. Okay. This also I'm giving 1. And carry I'm giving 0. And then run it. So your C out is supposed to be carry 1, and your sum is supposed to be 0. So yes, we are getting a correct output. Now we will give all the possible input combination of full header over here. So let's see how we can give it. So A, I'm taking it as 1, 1 bit 1. Then I'm changing it after every 4 nanoseconds. And then I'm changing it to 0. Maybe you can take for after 8 nanoseconds. We'll stop changing it. And over here. Then for B, initial, begin, B as 1 bit 1, forever, 2, B is inverting after every 2 nanoseconds, and we end over here, and then initial, begin. For C in, starting with 1 bit 1, 1 bit 1, forever, maybe for 2 nanoseconds. Then C in is inverting, or either you can write a 0 bit. Then after 8 nanoseconds we tend to stop it and end. And here it's a capital B. Let's save it. Now we will see creating a test bench for the full adder. So we'll close this first. Yes. And close this RTL schematic. Now here we will take a new source, and for creating a test bench we will take Verilog test fixture and naming the full adder as test bench as TB. Next, then for full adder we are creating, so select full adder and next and finish. So these are the inputs and outputs, and some wires are defined. So now here we'll give all the possible input combination of full adder over here. So let's see how we can give it. So A, I'm taking it as 1 bit 1, then I'm changing it after every 4 nanoseconds, and then I'm changing it to 0, maybe you can take for after 8 nanoseconds. We'll stop changing it. And over here. Then for B, initial, begin, B as 1 bit 1, forever to B is inverting after every 2 nanoseconds, and we end over here, and then initial begin for C in starting with 1 bit 1, 1 bit 1, forever maybe for 2 nanoseconds. Then C in is inverting, or either you can write a 0 bit. Then after 8 nanoseconds we tend to stop it and end. And here it's a capital B. Let's save it. So here are the all the possible combinations output A, B, C in, and here are the inputs A, B, C in, and outputs for all possible inputs. So here we end our today's tutorial by successfully creating a full adder and learning about what is instantiation, how to write a code using instantiation for full adder using a half adder, and then creating its test bench. So do like guys if you like the learning part, and share with your friends, and stay tuned with some upcoming new interesting tutorial, and keep learning. Thank you so much.